Imagine this. Everything you have ever seen, every star, every planet, every atom in your body, adds up to less than 5% of the universe. That means 95% of reality is invisible. We don't see it, we don't touch it, we don't fully understand it, yet without it, the universe wouldn't work at all. So, what is this missing universe? Let's talk about dark matter and dark energy simply. Let's start with something honest. Physics is not magic. It's bookkeeping. We write down what we think the universe is made of. We calculate how those things should move. And then we check. If reality doesn't match the math, something is missing. That's how almost every major discovery in physics begins. Not with an answer, but with an embarrassment. Now imagine this. You're looking at a galaxy. Hundreds of billions of stars, spinning together like a giant cosmic frisbee. Stars near the center move fast. Stars near the edge should move slower. Why? Because gravity gets weaker with distance. Same reason planets farther from the sun move more slowly. That's not theory. That's gravity working perfectly everywhere we tested it. So scientists did the math. They added up all the visible matter. Every star, every glowing cloud of gas. They calculated how fast those stars should orbit. Then they measured how fast they actually orbited. And something went very wrong. The stars at the edges of galaxies were moving way too fast. Not a little fast. Not within error bars fast. Dangerously fast. Fast enough that galaxies should have torn themselves apart billions of years ago. But they didn't. They were still there. Perfectly intact. Rotating calmly, as if held together by something invisible. At first, scientists did what they always do. They blamed the instruments. They blamed dust. They blamed bad data. But the problem didn't go away. Different telescopes, different galaxies. Same impossible result. And then came the most uncomfortable moment in science. When you realize either the universe is wrong or your understanding is incomplete. This mystery was studied carefully by Vera Rubin. She didn't shout. She didn't speculate wildly. She just kept measuring. Galaxy after galaxy. Rotation curve after rotation curve. And every time, the same answer appeared. There was far more gravity than visible matter could produce. So, scientists were forced into a corner. There were only two logical options. Option 1. Everything we know about gravity, from falling apples to planetary motion, breaks down at galactic scales. That would mean rewriting physics from the ground up. Option 2. There is extra mass we cannot see. Mass that does not glow, does not shine, does not block light, but still pulls on everything. Physics prefers the second option. Not because it's comfortable, but because it explains the data without breaking everything else. And that invisible mass was given a simple name. Dark matter. Not dark because it's evil. Not dark because it's mysterious. Dark because it doesn't interact with light. Here's what we know about dark matter for sure. It does not emit light. It does not absorb light. It does not reflect light. That means no telescope can see it directly. But it does have gravity. And gravity is honest. You can hide mass from gravity. If something pulls, it leaves a trace. And we see those traces everywhere. We see them in how galaxies rotate. We see them in how galaxy clusters bend light behind them. A phenomenon called gravitational lensing. Light curves around invisible mass. Like water flowing around a rock you can see. The universe is full of these invisible fingerprints. Here is the key idea. We do not believe in dark matter because it's fashionable. We believe in it because without it, the universe collapses into nonsense. Galaxies wouldn't form. Stars wouldn't stay bound. Large-scale structure wouldn't exist. Dark matter is not a guess. It's the simplest explanation for what we observe. And yet, despite knowing what it does, we still don't know what it is. Not atoms, not light, not anything in the standard model, which means the universe is not only stranger than we imagined, it's stranger than the tools we built to understand it. And this is only the beginning, because dark matter explains why galaxies hold together, but it does not explain why the universe itself is flying apart. That mystery is even bigger. And that's where things get truly unsettling. Up to this point, the universe was strange but understandable. Galaxies held together by invisible mass, uncomfortable, yes, but at least gravity was still in charge. Then physics made a discovery that no one was trying to find, and that's usually when things go wrong. Let's rewind. For most of the 20th century, scientists believed one thing about the universe. It was expanding, but slowing down. Why? Because gravity pulls. Every galaxy pulls on every other galaxy. Expansion should gradually lose momentum. That idea was so reasonable that nobody seriously questioned it. The universe expands. Gravity applies the brakes. End of story. So astronomers set out to measure how fast the expansion was slowing. They used exploding stars. Type EI supernovae. These explosions are special because they all explode with nearly the same brightness, which means if one looks dimmer, it's farther away. If it looks brighter, it's closer. They are cosmic mile markers, perfect for measuring the universe. Then the data came in, and the universe refused to behave. Distant galaxies weren't slowing down, they were moving faster. The farther away they were, the faster they were receding. Not slowing, accelerating. This result was so shocking that scientists assumed it was wrong. They checked the data, then rechecked it, then had other teams repeat the experiment. Different telescopes, different methods, same answer. The expansion of the universe is speeding up. This was not just unexpected, it was catastrophic. Because acceleration requires energy. Something had to be pushing. But there was nothing there. No particles, no radiation, no force we recognized. Just space. So, physicists did something very human. They gave the problem a name. Dark energy. Not because they understood it, but because they didn't. Here is what we think we know. Dark energy is not matter. It doesn't plumb. It doesn't form galaxies. It doesn't pull things together. It pushes them apart. Even more unsettling, it doesn't weaken as space expands. It grows with space. The more empty universe you have, the more dark energy appears. This is where things get deeply uncomfortable. Because empty space was supposed to be empty. But according to modern physics, empty space has energy. And that energy has pressure. And that pressure is strong enough to overpower gravity on cosmic scales. Ironically, this idea was written down decades earlier by Albert Einstein. He added a term to his equations, a constant energy of space itself. Later he called it his greatest mistake. Turns out, the universe didn't agree. Today, dark energy makes up nearly 70% of everything that exists. Not stars, not galaxies, but something built into space itself. Which means the fate of the universe is not controlled by matter, but by emptiness. And here is the most honest sentence in modern cosmology. We have no idea what dark energy actually is. We can measure its effect. We can model its behavior. But we cannot explain its origin. Every theory struggles. Quantum physics predicts a value that's wrong by a factor of 1/120. That's not a small error. That's the worst prediction in the history of science. So when physicists say, we think we know, what they really mean is this. We know what it does. We do not know what it is. And we don't know why it exists at all. Dark matter tells us we don't fully understand matter. Dark energy tells us we don't fully understand space. And when you put those together, you realize something unsettling. Everything you see, every atom, every star, is just a thin layer floating on top of a much deeper mystery. And now comes the most disturbing part. If dark energy continues to dominate, the universe doesn't end in fire, or collapse, or silence. It ends in isolation. Galaxies drift apart. Stars fade beyond reach. The night sky goes dark. Not because the universe dies, but because it keeps expanding forever. So now, let's do something very simple. Let's add it up. All the stars, all the planets, all the gas, dust, people, trees, oceans and atoms. Everything you have ever touched, everything any telescope has ever photographed, adds up to about 5% of the universe. That's it. The remaining 95% does not shine, does not glow, does not interact with light at all. Which means this, the universe you see is not the universe that runs the show. This isn't poetic language. It's biology. Your eyes evolved to detect light because light bounces off atoms. Atoms grow, scatter, reflect. But dark matter doesn't do that. Dark energy doesn't do that. So, to your senses, they don't exist. Not because they aren't real, but because you were never built to see them. Think about that. You are living inside an ocean and can only see the foam on the surface. The waves underneath the current shaping everything are invisible to you. Telescopes don't fix this. Bigger mirrors don't fix this. More sensitive cameras don't fix this. because telescopes are just extensions of your eyes. They still rely on light. And most of the universe doesn't speak in light at all. Dark matter doesn't announce itself. It doesn't glow like stars. It doesn't scream like explosions. It just sits there, quiet, massive, pulling. Galaxies form around it like frost, forming around invisible wires. We don't see the wire, only the shape it forces everything else to take. Dark energy is even stranger. It doesn't pull, it doesn't clump, it doesn't form anything. It stretches space itself, which means you can't point to it. You can't isolate it. It's everywhere and nowhere at the same time. So when people ask, why is the universe invisible? The honest answer is, because reality does not care how human perception works. This is where humility enters physics. As Richard Feynman once warned in his own way, if you think you understand the universe, you probably don't. That's not an insult. That's a reminder. For centuries, humans thought if we can't see it, it isn't real. Then we discovered bacteria, then radio waves, then X-rays, then quantum fields. Each time, reality expanded beyond our senses. Dark matter and dark energy are simply the next step in that lesson. Here's the key realization. Science didn't fail because we don't know what these things are. Science is working because it admits that we don't. Pretending certainty is comfortable. Admitting ignorance is productive. Dark matter tells us something unsettling. We don't actually know what matter fundamentally is. Not completely. Dark energy tells us something even deeper. We don't know what empty space really means. And suddenly, the universe changes character. It's no longer a place filled with objects. It's a place where absence has power, where emptiness dominates, where what you cannot see controls what you can. This doesn't make the universe meaningless, it makes it honest. It tells us we are beginners, still learning the alphabet of reality, still mistaking the surface for the whole story. And that is not a failure, that is the frontier. Because every time physics discovered something invisible before, it changed everything afterward. So the universe is not hiding from us. It's teaching us something far more important, that seeing is not understanding. And that the greatest truths are often the quiet ones, the ones that don't glow.